Hi, this lesson is about special factoring. We'll be talking about the difference of perfect cubes, perfect square trinomials, as well as the sum and difference of perfect cubes. So let's start with the difference of perfect squares. So the formula for to factor the difference of perfect squares, so the perfect square would be a squared minus b squared. The factors for that would be a plus b times a minus b, where a and b are just the square root of whatever a squared and b squared are. So what are perfect squares? Numbers like 4 or 9, 16, 25, etc. But they could also be variables like x squared, y squared, etc. Okay, so here are several examples. Number 1, we want to factor x squared minus 9. X squared and 9 are both perfect squares, and it is a difference. So the factors are x plus 3 and x minus 3, because the square root of x squared is x, and the square root of 9 is 3. Okay, let's go on to the next one. So we have 4y squared minus 81. Again, both 4y squared and 81 are perfect squares, and we are subtracting them. Square root of 4y squared is 2y. Square root of 81 is 9. So our factors are 2y plus 9 and 2y minus 9. So just like any other factors that we've done in the past, you can check any of these examples. I'll do a check here. Your check would be to FOIL these two binomials, and if it equals the original expression, then you know you factored correctly. So my first term is 4y squared. My outer term is negative 18y. My inner term is 18y. And my last term is minus 81. The negative 18 and positive 18y cancel. So you get 4y squared minus 81. That's exactly what we started with. So it checks out. So when you're multiplying these factors when you're factoring a difference of perfect squares, when you have the same two terms with a different sign in between, these are called conjugates. And that word will be used in several lessons throughout this course. And what happens when you multiply conjugates is that your outer and inner term cancel out, just like they did in this example. All right, next example, 9x squared minus 25y squared. This is also the difference of perfect squares. This one's a little different in that I have variables in both positions, but the square root of 9x squared is 3x. Square root of 25y squared is 5y. So your factors are 3x plus y, 3x plus 5y, and 3x minus 5y. If you write them in the opposite order like this, 3x minus 5y and 3x plus 5y, that still means the same thing. So either way, these are equivalent. Either way, you can write it in either direction. All right, so let's move on to the next one. I have 100a squared minus 94b squared. Again, both are difference of perfect squares. So I have 100a squared, the square root is 10a. Square root of 49b squared is 7b. So your factors are 10a plus 7b times 10a minus 7b. Okay, and then here's our last example. What's different about this one is that I have a sum, not a difference. So x squared and 36 are both perfect squares, but when you have a sum of perfect squares, those cannot be factored over the real numbers. So this is non-factorable over the real numbers. So you might get some homework that looks like that. All right, so let's move on to perfect square trinomials. Perfect square trinomials are trinomials that are considered to be perfect squares because when you factor them, it's the same factor twice. In other words, a squared plus 2a plus b squared would be a plus b times a plus b. But because it's the same factor twice, we can write it as a plus b to the second power. And the same thing is true for the second formula. The only difference is that I have a minus in between. If you were to factor that, that would be a minus b, and so that would just be a minus b squared. Okay, so these are perfect square trinomials. The first two are like the first formula. These are here in orange. And the second two are like the second formula, and those are here in blue. So x squared plus 10x plus 25, well, if you factor that, that would be x plus 5 times x plus 5. That's just x plus 5 squared. Z squared plus 14, this should be a z, plus 14z plus 49, that would be z plus 7 to the second power. And x squared minus 6x plus 9, well, that would be x minus 3 to the second power. And y squared minus 20x plus 100, that would be x minus 10 times x minus 10, which is just x minus 10 to the second power. So you could factor these perfect square trinomials the same way we did in previous lessons, just looking for combinations of numbers that give you a product of 25, for example, and a sum of 10, and you would get this result. So you don't necessarily have to memorize the formulas above. Okay, let's go on to the perfect cube formulas. There will be two formulas for the sum or the difference of perfect cubes. The first one is for the sum of a perfect cube. So if you have a cubed, so in other words, this being your perfect cube, plus b cubed, so that being the sum of perfect cubes, the factors would be a plus b times a squared minus ab plus b squared. And the second formula is really similar. A cubed minus b cubed. This time it's a minus b. Notice that the sign here matches with this. Same thing here. But when you do the trinomial, this middle term should be positive, and in the sum, this middle term is negative. Otherwise, everything else about the two formulas are exactly the same. So this is something to keep in mind when you're factoring. Sometimes you have perfect cubes and you're not trying to figure out any particular combination of numbers. You really just have to plug into these formulas. So before we practice factoring, let's familiarize ourselves with some numbers that are perfect cubes. So 1 is a perfect cube, 8 is a perfect cube because 2 to the third power is 8, 27, 64, 125, 216, 343, 512, 729, and 1,000. There's infinitely many of these, but these would most likely be the most common numbers you would see like on your homework or on a test. So you want to be familiar with them. Writing things down and saying them out loud is a good way to help you memorize things. All right, so here's our first example. We want to factor x cubed plus 8. So x cubed is a perfect cube because x times x times x is x cubed. 8 is a perfect cube because 2 times 2 times 2 is a perfect cube. So the trick in terms of plugging into the formula, and I'm just going to write the formula here just to so we could follow along. This is a plus b times a squared minus ab plus b squared. Okay, so in order to plug into this side, I need to figure out what a and b is. Well, the a and the b are the expressions that are multiplied 3 times to get this and this. So a is x and b is 2. So now we just have to plug in the a and the b into the formula. That's it right here in this box. So the factors are x plus 2, that's the a plus b, times a squared, now remember a is x, so that's x squared, minus, and remember next is a times b, so what's a times b? That's x times 2, which is 2x, plus b squared, and b squared is 2 squared, which gives you 4. And once you do that, you're done. This trinomial is not factorable, so there's nothing else for you to do. You have actually answered the question. All right, so let's go on to the next one. Here I have y cubed minus y 125. Again, this is the difference of perfect cubes, so it's a similar formula. I'll again write it down here so it's easy to follow along. This will be a minus b, a squared plus ab plus b squared. Okay, so I need to plug into this part to factor it. So what's a? A is y, because y times y times y gives me y to the third. B is 5. Why? Because 5 times 5 times 5 is 125. Once you know what A and B is, you're just plugging into the formula that's here in this box. So that will be y minus 5 times y squared plus, now remember, this middle term is AB, and so what's AB? That's 5 times y, 5y, plus b squared, which is 5 squared, and that's 25. Okay, let's move on. Here's another sum, so we can refer back to this formula up here. 27z cubed plus 1. My a is 3z, because 3z times 3z times 3z is 27z cubed. My b is 1, because 1 to the third power is 1. Now we plug into the formula, the first formula right here. So we have 3z plus 1 times, now remember, it's a squared, which means square this. So that's 9z squared minus, and then it's ab, that's this times this, so that's minus 3z, plus b squared, which is 1 squared, and that just gives you 1. All right, here's another one with a difference. So we're referring to this formula. I have 8x cubed minus 343y cubed. All right, so what's A? A is 2x, B is 7y. We plug into this formula, so I get 2x minus 7y times, now remember this is a squared, so that's 2x to the second power, that's 4x squared. This is AB, so that's 2x times 7y, that's 14xy, plus b squared, which is 49y squared. Okay, now we have 27 as m cubed plus 64n cubed. All right, 27m cubed, that means that a is 3m. My b is 4n, because 4n times 4n times 4n gives me 64n cubed. Then we have to plug into the first formula. So that will be a plus b, this is the a plus b, times, and this is a squared minus ab plus b squared. So we get 3m plus 4n times 9m squared minus 12mn, in other words, these two get multiplied, plus b squared, which is 4n to the second power. All right, so here's one more that requires a little bit more work. We have 64x to the fourth minus 54x. This is definitely not the difference of perfect cubes, and it's also not the difference of perfect squares, but I do have a GCF. Here, these two terms have a GCF of 2x. And remember, you should always look to see if your polynomials have a GCF, and that always gets factored out first. So we take out the 2x, and that leaves us with 8x cubed minus 27. Now, this is the difference of perfect cubes. So I have that a is equal to 2x and b is equal to 3. Then we plug into the formula. So remember, just keep carrying down that 2x. That's one of the factors. But here the formula will be the second formula. This is a minus b times a squared plus ab plus b squared. So the 2x times 2x minus 3 times 4x squared plus 6x plus 9, all three of those factors are the factors of the original polynomial. Okay, so that's it for this lesson. Give the homework a try. Good luck.